Today we will answer a very good question. What happens when we exceed the allowable range of any data type? In this lecture we will discuss the range exceeding condition for integers, both signed and unsigned. And a similar concept is adapted to other data type as well. So let's get started. In this example I have given an integer variable, an unsigned integer variable, the value 4294967295, which is the maximum allowable value for an unsigned integer for 4 bytes. Let's see what happens when we execute this code. And this is what we are getting as a result, 4294967295. Now this is quite expected, right? Let's change the code a little bit. I increased this code by 1 and made it 4294967296, and see what happens if you try to go beyond the range. We get a warning, but if I ignore this warning and see the outcome, we have the value 0. Now this is quite weird, isn't it? To understand why, when we try to exceed the range, we return to 0, we need to take a short example to help illustrate the point. In this example, I have taken 3-bit data and written all the possible 3-bit representation. For a 3-bit representation, we can say 000, 001, 010, 011, 100, 101, 110, 111. We are having the value from 0 to 7 for 3-bit representation. The minimum value would be 0 and the maximum value would be 7. And this is the scope of our 3-bit data, you can say. Let's see what happens when we try to represent the value 1 greater than 7, which is 8 in this case. This value 8 can't be represented in 3-bit representation. As you can see, the 4th bit place value is equal to 2 raised to power 3. As the result, if you want to represent the value 8, you must set this bit and reset all other bits. Simply means we need to set this 4th bit to 1 and reset all other bits to 0. If we force ourselves to represent the value 8 in 3-bit representation, then we would not be able to do that and we will left with only 3 bits. Because this 4th bit can't be represented in a 3-bit representation, therefore we can say that this value is equal to 0 in a 3-bit. As in a 3-bit representation, this 1 bit is hidden and equal to 0 with the rest of the bits. If you want to represent the value 1 higher than that, which is 9, we would not be able to do so because the 4th bit is not available for us and we only have the 3 bits. Therefore, whatever is there inside the 3 bits, we would be able to represent that only, and that is equal to 1 in this case. If we try to represent the value 10, we are not able to do so because this 4th bit is not available for us. In fact, this value is equal to 2 in decimal. As we can see in 3-bit example, our range is from 0 to 7, and if we try to exceed the range, we return to 0 like a cycle, and then 1, then 2, then 3, and so on. Starting from 0 itself up to 7, and then 0, then 1, then 2, then 3, and then 4, then 5, then 6, then 7, and again 0, 1, 2, 3, and so on. Similarly, if we try to exceed the range of 32-bit representation, we must contain one extra bit, 33rd bit. However, because we only have 32 bits available for us, we are not able to represent value greater than the maximum value and must return to 0. Let's now discuss the signed range. The signed range is a little bit different, but the idea is same. Look at this 3-bit representation once more. According to the 2's complement representation, the signed range of 3-bit data would be -4 to +3. Now, let's see what happens when we try to exceed the range by representing the number in 2's complement. However, it would be much better if we try to imagine this in a different manner. Let's look at it another way. As we know, the range of a 32-bit unsigned integer is 0 to 4294967295. And if we try to exceed the maximum value 4294967295, to 4294967296, we return to 0. As an analog clock, after 12 o'clock, we return to 1 o'clock. Therefore, in a similar case where the range of a signed integer is from -2147483648 to +2147483647, when we try to exceed the maximum value, that is +2147483647 to +2147483648, we actually get this value, -2147483648. As we did in case of unsigned, when we exceed this range, we will return 0. Similarly, when we exceed this, we return to minimum value. And if we try to represent the number -2147483649, which is 1 less than the -2147483648, that is the minimum value, we get back to the maximum value, +2147483647. Let us try to confirm this using a program. I have provided a signed integer variable here. The integer variable is signed by default, and the maximum value for a signed integer value is 2147483647, and this is one more than that, 2147483648. Let's see what happens when we run this code. As you can see from the outcome, that is to be expected, that is -2147483648, the smallest possible value for a signed integer variable. Let's change this code a little bit. Change this to negative value, make it 9. And this is what we are getting as a result, 2147483647, which is the maximum value of a signed integer. As I said earlier, the same concept is adapted to other data type as well. So when we try to exceed the range of any primitive data type, then we come back again to the minimum value. Okay friends, that's it for now. See you in the next one. Bye bye.